Okay, so it's the 1st of September. Yes, I've been sneezing a bit today. So we're doing 3 chapters are supposed to be this week. Of course, network security concepts is sort of an overall overarching look at network security. Then chapter 4 is ACL concepts. So of course, access control list it stands for. And of course, chapter 5 is actually implementing access control lists. And so that's what we're looking at today. Next week, we look at NAT when it comes to the activity. Now, the reason that ACLs is before NAT is because we actually need to be able to use ACLs to be able to do dynamic NAT. So that's why it's in this order. And so, of course, September the 15th, joys. The practical test. So, of course, starting up the last week's topic, OSPF. And so, of course, I did demo last week, something along those lines. Hopefully, yeah, I haven't quite, I should have a trial practical available by the end of the day today. That should be the plan. It's not quite finished yet. So anyway, so that's what we're up to today. So, of course, we're going to use Packet Tracer to demo it. And so I've got a network here. So of course 3 routers, 4 LANs, and so we're going to play around with security settings. So first thing we'll do is I'll just ping all the other hosts. So ping 192.168.10.10 is probably itself. It worked though, that's always a good sign. Now, the host on the other network next to it, this one here is 11.10. So might need an ART request or 2 to get that to work, but should happen. All looking good. And so as you can see here, this is 192.168.30. And then it's going to be 10 for the host. So I'll just edit that. So of course this is now going across those 2 WAN links to this router and then down to this PC and working. And then we've got a server on this network of 31. So I'll just go back and test that. So yeah, so the routing is all working nicely. And of course, we've got all connectivity between all the other hosts, all the hosts. So that's all good. So we've got a good starting out situation. Now we're going to sort of play around with some settings and add some security, basically. So first thing we're going to look at is standard ACLs. And so, of course, the standard ACL, the only thing you can specify is the source address. And so that's pretty much what you're limited to. And so here, of course, this is a numbered standard ACL. And so basically each access control entry needs to have the same number, just so they know they're on the same list. And so, of course, with this access list 10, of course, the number is important. If it's between 1 and 99, it's a standard ACL. If it's from 100 to 199, it's an extended ACL. And of course, there are other ranges further up in the numbers as well, just in case 100 of each isn't enough. And so, of course, it's access list 10, and the action for this line, if we get a match, is to deny that traffic. And so we're actually specifying a host, and that host is 192.168.30.10. Now we're applying this ACL to R1 over here, and of course that actually matches this host here. Now I've got this line here, access list 10, permit any. What does that do? It is pretty much self-explanatory. So any host address will match that one, and they will be permitted. So the order in which you put these lines in is important. If I'd put this line before that line, any host would match this one, and everyone would be permitted. And so here we're just trying to block this one host. And so basically the order they're in is important. And so the more specific lines need to be at the top of your access list typically. So of course this is more specific because it's just one host that's going to respond to basically. So that's the access list defined with these commands. You then need to apply it to an interface. And so we use the IP access group command to do that. We then give the number to identify which list. And then we need to specify a direction, and so inbound. So on R1 on S000, S000 would be this one here. So it's coming in here. So this host should not be able to ping either of these hosts because incoming it'll work. So let's try it first. I haven't done it in that direction. So ping 192.168.10.10. It's working nicely. And of course, the other host is 11.10. That's working nicely as well. So let's see how this access list affects things. Copy. Paste. Now I don't see any errors, that's good. And so it's gone into S000. Now we can do a show run. And we'll see that on S000, you can see the IP access group command is there. And then if we look further, we'll actually see where the access list is defined. And so of course that looks identical to what we did. So I'll ping from this host to start with. This should work. Ping 192.168.10.10. That's nice. By 11 as well, and it is. Now this is the host that's been blocked. And so it worked before. We're actually getting a response back from the router saying that destination host is unreachable. It's not saying, sorry, pal, you're blocked, but, you know, you can't reach it is also true, I suppose. Just not quite as informative. So now that access list has worked, and so you can actually now do show access lists, and you can see how many matches you've got for each. And so you can see that this has got 8 matches because I pinged both this host and that host, and of course it was 4 packets each, and I've got 11 matches for that. I'm not exactly sure what that was, but anyway, some of them were these, and so that's all working very nicely. And so having these match counts when you've applied and tested an ACL is a very handy thing to have. Okay, so that's a standard numbered access control list. All right, the next one is going to be a standard named access control list, and we're going to apply it to R3. And so here we do IP access list standard other. So of course, other is the name of the access list. And so we are denying a subnet. So 192.168.10.0. So no hosts from this subnet would actually be able to ping or get through this access list, but all other hosts will. And now, of course, you always need to have a permit statement. Does anyone know why? Yes, there's actually an implied deny any at the end of the list. Yeah. And so if you don't have a permit statement, you might as well just unplug the interface because nothing's getting through. So it's a lot easier just to pull a cable out, isn't it? And now, of course, we need to apply it, and we're applying it to int G0/0, which of course is, I think, this interface. Yes, it is. And so IP access group, not a number this time, it's called other and outbound. And so, of course, it's going out of the router. And so we're just blocking this subnet's access to this subnet. So this subnet is being blocked from getting to this subnet. That's what this one is doing. And so we'll apply that. Don't see any errors. Again, if we look at show run, notice that IP access group other is outbound. And then if we go down a bit further, we can see that other is there. Now, when I pasted it in, when you do IP access list standard other, it actually changes you into standard named access control list mode. And so, of course, with this one above, I had to say that each access control entry was what list it belonged to. With this, I don't need to because we're in a specific sub config mode. And so basically all the commands I put in here are now going to belong to that access control list named other. And so that's what's happening here. Of course, as soon as I put in an interface command, it's going, oh, okay, well, that's going to change your mode to something else. And so, of course, that's applying it. And so that's basically how it all works. You don't, so the named access control lists are, yeah, a lot easier to do actually. And also you can actually edit them as well. But so let's try that out. So we've blocked this subnet from getting to this subnet. So let's try pinging that host again. So 30.10. It worked before. It's not working now. So that access list is blocking it. But if I try 31, it should actually work because it's only that G00 that's blocking it. G01, which is where the server is connected, is working. So there we go. We've got another ACL applied. And so now if we look at this and go show access lists, we can see that we've had 4 matches for this. I suppose if I tried pinging that host from here, we'd get some matching the any line. Ping 192.168.30.10. Mathematically, it should work, but whether the command takes it, not another thing. So this should work. Oh, I guess what I'm guessing is I've actually got an access list applied for this host, haven't I? This host can't get through that router. So the pings, I'm assuming, are getting all the way to this host, but when it replies, it's hitting that first access list I did, and it's blocking. Isn't it on the way in? Yeah, that's what I'm saying. The replies from this host are actually getting here, and they're getting blocked. Yes. That's why I'm not getting unreachable. It's actually this one that's getting the unreachables. But of course, I'm sitting at that one. So, yeah, all right. But of course, they will, it still would be able to ping 31. Yes. All right, so that's a standard named ACL. So, of course, with the standard one, as I said, you can only specify the source address. Be that a host or a group of hosts. With this extended, you can actually specify source and destination, as well as protocols, port numbers, and other stuff like that. So we've got another ACL we're going to apply to R1. And so, of course, it's an extended ACL because it's 100. The first line is going to permit traffic. And this one will only match traffic that's using TCP. And so the source address, sorry, is the web server. and I'm only permitting web traffic. So that is the source definition, this part here, because it's source then destination. And so the source is the web server for web traffic only, and it can go to any destination. Now, of course, I didn't actually need to put this line in, deny IP any, because that is an implied line. Now, the reason I put it in is, remember I was looking at all the match statistics for the access control list? Well, you don't actually get a match numbers for the implied lines. And so by putting this in the ACL, I will actually know what is when traffic is matching it. So that's just a little bit of extra information. That's why I've done it.
Would it be the same for the standard?
Yes, it is. So yeah, when I'm actually doing real access control lists, I actually normally put the deny any on the end, just so I can have a look at the statistics. All right, so that's allowing traffic through that comes from the web server, web traffic from the web server. Where are we applying it? So we're applying it to G00 outbound. So it's basically traffic going out there. And so let's have a look at that. Copy, paste, and away we go. All right, so let's do a show run now. And so on the interface, you can see IP access group 100 outbound. And now we've got two ACLs. There's ACL 10 and ACL 100. All right. Now, if I ping the web server, it actually should not work. Web server. And again, looks like I'm going to get timeout messages because it's actually the return traffic that's being blocked. Because it's coming from the web server, that's nice, but it's not web traffic, so bad luck. So the ping, of course, doesn't match web traffic. But if I actually browse to the web server using a web browser, 192.168.31.10, it should work, and it does. So the web traffic's getting through, the ping traffic is not. So that's exactly how that access control list is specified. So show access lists. And so you can see that there were 3 packets to get the web page. 2 of them would have been the SYN and the ACK. The other one would have been the web page. You're talking about the port number? Yeah, you could. By all means. Actually, the next extended one is probably a little more typical, but anyway. And so as you can see, there were 3 matches for the ones that succeeded and 4 matches, of course, for the pings that were denied.
It's funny how it says equals www.
Yeah, actually, if we look at the show run, it's actually translated it because I did 80. It just knows that port 80 is www.
So would it block HTTPS?
It would at the moment.
Yeah. That's a different port. That's port number 443.
Yes. So if we look at the next ACL I'm going to do, look, I've done both. So you need 2 lines. All right. So on router 3, we're going to do an ACL again. Now we're going to permit traffic from any source to that host with a destination port of 80 and any host to that host with a port of 443. This is probably a more common solution for a web server, is that you would actually protect the server itself. And so, again, I've got the deny IP any on the end. And so I'm applying the IP access group web out. So again, basically any traffic that comes in, of course, this could be the rest of the world. The only ports I'm letting through are that destination ports of 80 and 443. So we'll apply that. So no problems there. Show run. So you can see, oh, it's G01, that's right. IP access group web, because that's what I called the access, the name, that's the name of the access list. Web outbound. And I need to undo there. I hit spacebar and deleted it. So that's the access list defined. All right. Now this PC is going to be a little bit strange because it's only, I've got the access control list here, only letting port 80 through. So it will work for 192.168.31.10. That should work. As soon as I try to use port 443 though, oops, S, I don't know why I did it too. That should actually not work. And so if we wait a while, it'll probably come up with a timeout message or something along those lines. Yeah, because there's the ACL on here that only lets port 80 through. But if I do it from this host, it should work a treat. That worked. Now, what I might do is I might close the browser and open it again just to make sure that we know that. And now I'll throw the ES in. And port 443 worked as well. So that's nice. Let's try pinging.
People like gain access to that web server if you're only allowing 480 and 443?
Well, they'll be able to gain access to it as a web client, but that should be the only way.
Yeah.
And so ping didn't work because I'm only letting through. So let's have a look at this and have a look at the show access lists. And so you can see that I've had 10 matches with the web page, 17 matches with the secure web page, and 25 matches with denied traffic. Yeah, I'm gonna say there's always a way around it,
Yeah.
but typically with lines like that, they would have to be looking at flaws in the web server. So they would be able to access the web server using it as a web server.
Yeah.
But of course, every software's got faults in it.
Yeah.
And so, yeah. So that if they'd be able to find out what type of web server it is and what version of the web server it is, and then there are normally vulnerabilities. And so if there are unpatched vulnerabilities, that's often the way they get in afterwards. But anyway, that's typically the way. Now, for some reason, for version 7 of the curriculum, they only show us access lists for IPv4. They don't look at IPv6. So, yeah. What?
It's too long to type in.
Well, it's actually, because yeah, version 6, this is actually, I've just adapted this from the version 6 one I did. They're actually not greatly different. So this is there's only named access control list for IPv6, and there's no such thing as a standard one because we don't really need it. But anyway. Well, standards are a bit of a blunt tool, but actually the last thing I'm going to demo is a fairly cool solution. Now, in the chapter, it also talks about protecting your VTY lines on your devices.
That's a good use of standard.
Yeah, because it's very quick and easy, and just as efficient as an extended. So, first part here, I'm just going to applying some passwords so I can actually remotely access the router. Otherwise, yeah, without any passwords, you can't tell NAN in at all. So that's the first thing I'm doing. Then we've got an ACL that we can use for the for that. Now, what I'm going to do is I'm actually setting this host to be the management host. And so as you can see, access list 20, permit host 192.168.30.10, which of course is this host here. I've got no other lines. It's just that one line. Of course, so that host is permitted. All other hosts will match the deny any. Or deny any, sorry, it's a standard one. And so you can then apply it to your lines VTY by doing access class 20 inbound. Now, the beauty of this is, well, we already know who the destination is and we can specify it. Because, hey, if this is matching it for the VTY line, well, hey, the destination is either Telnet or SSH. So that's cool. And of course, then here, we've only got one host that's permitted to connect using Telnet or SSH. So it's as good as an extended one. Another good thing about this is this will only restrict access to the router for Telnet. It actually won't hinder its movement through the router to anywhere else on the planet at all. And so it's just protecting your router and nothing else. And so it's as I said, it's as good as extended ACL because it's very finite about what it's applying it to. Now, first up, I'll connect to that. Before I apply the ACL, I'll use this host to be able to connect in. Can't use the other host because that only lets web traffic through. So I've got to use this host. And so, of course, I'll select Telnet 192.168.30.1. I'll connect. Hey presto, Cisco is a password. I'm into R3. So that's working at the moment. So I can go enable class, and now I can do anything I like on that router. So not secure at the moment. I'll exit. Now, I'll apply the ACL. Now, as you can see, you don't do access group or access list, you do access class on a VTY. So that's been applied, it's all good. We do show run. There's that new access list there. And if we look at that, we've got access class 20 in. Now there is a bit of a gotcha with this though. If I do conf t line VTY 015, we'll do question mark. You'll see that of course there is the access class command. But there's also IPv6, and so if I do IPv6 question mark, IPv6, not PIv6. There is an access class command for that. So if you type in IP access class, it will actually due to the automatic completion of words, actually translate that to IPv6 access class. So you've got to be careful. If it's IPv4, you just do access class. If you do IP access class, it will actually be an IPv6.
That means you can still access.
I suppose when you do it, the commands will be wrong because you'll be putting in.
Yeah, well, it just won't be very effective because it's going to be applying an IPv4 access class access list to an IPv6, and that's, yeah, it's going to be strange.
That's only allowing that. That's what all it doesn't even touch it.
No, it won't affect IPv6 because it's a different protocol.
You can access that.
Yeah, you would be able to. All right, so let's test this again. Let's see if we can. We should now not be able to telnet into that router. 192.168.31.1. No joy. So, of course, that is not the approved host. This is. So we'll go down to here, try telnet. 192.168. Oh, God. 31.1. This one can connect. EN. All good. So no other hosts can get in, just that one. It probably would. Oops, I don't need the prefix. Copy. Not exactly sure why that didn't work.
Oh, there's 9. There's 9 from default, or is it?
I can ping it. I can't telnet it. All right, well, let's end. Show access lists. And so you can see I've got 2 matches there. And of course, because I didn't do a deny any, I don't know how many fails there were, but I've got to admit that it is strange that I wasn't able to telnet in using IPv6.
Is creating an access list with IPv4 automatically deny all IPv6?
No, because you need to do it separately. But anyway, that was pretty much all I was looking at demoing today. And so yeah, this file is. Draw this. These files are available on the Cisco site. So so there we go. Here's and so the Chapter 5 demo is there, and as well as the text file. I will actually update it. I've done a little bit of editing since, but yeah, I will update that shortly. So that is all available. Does anyone have any other questions at all?